Okay. Okay, okay, so now it's working. Oof. So stuff keeps breaking in between streams, which is not great at all. So the Spotify integration is also broken, so you won't see the notification. I don't know why. I will need to fix that for the next time. Let me put this here, this one here. Okay, and we can finally start with the stream. So hello everyone, I don't know who is there or not, but anyways, welcome to anyone watching live or on replay. What we are doing today, as I teased out, is that we will be taking a look at the improvement I made on the collide and slide. So I'm actually currently trying to debug another issue that I got on the stepping, but if we zoom in on this part, so I've enabled the collision between two characters, and I enabled collision with rigid body objects. So now I can push the objects, and I can control the, let's say, intensity of the push or the force that I apply by controlling the mass of my object. So if I put a bigger mass, it will push much harder on the object. So it's up to you to define how strong you want to push back. And actually it also depends on the actual mass of the object. So if I put 80, so let's set all of them to 80 and the character to 80 also. It should be the same thing as if it was 1-1. So you can see it's pushing them, but less strongly, let's say. So I will set that back to 1. And not everyone had the same mass apparently, but that's okay. And I also fixed the stability issue with the shell. So if I pick this one, for instance, and I say that the shell is much bigger, it's stable, and it is indeed using the shell width to stay away from the collision. So that's good also. And now the only bug that remains that I found is in the stepping logic, because if I go to this one, there is an issue, and that's what I was trying to debug. So here you can see the yellow capsule, the shrunk down version of the capsule that I'm using to detect if I can step over something. So basically I'm using the maximum step height as the base of the capsule cast, and for the top I'm not using the full character height, but I'm using the character height reduced by the size of the step that I'm trying to step on. So that should give me theoretically the fact that, okay, I'm hitting my head, so I can't pass through this tight gap. But if I continue to step, you will see that at some point, next step, the collision will not return any hit, and the capsule is snapped to the maximum height position, and in fact it should be snapped at the step height. So that's something I need to fix. So let's take a look at that. So this is the logic that I apply when I'm stepping. So I try to or I compute first the height of the step, basically. And then I compute the shrunk down version of the capsule, which is what I'm drawing here. I'm doing a cast forward of that capsule, and to have that I'm using cast distance, which is basically the distance that I want to go in front of me, plus half of my character, so the capsule radius, because I want to stay on to be able to stand on the object that I'm trying to step on. And if I collided, I will move only if and this is the issue. So I move only if I have enough space to stand on the stuff. Thank you for the follow. Hello, Ratsui. Welcome. It's doing fine. I think I'm almost done with the collide and slide logic, or collision response logic, rather, for my character controller. So I will just quickly try to fix this last issue, and then I will jump into the numerical integration. So looking at different method of considering movement, like Euler, I'm sorry for the French accent, Euler, semi-implicit Euler, Verlet, and velocity Verlet. So we'll check that. Spain! Nice! I went to Barcelona with the family this summer, and then again in September for Unite, so it's a very nice country. I got to say, I didn't quite like very much the beach at Barcelona. It was much more interesting in, I think it's Costa Blanca, something like that. We went on a tour, and it was there were better beaches than in Barcelona. But we did enjoy the trip. We visited a lot of stuff, including the Sagrada Familia, which we were lucky to visit. Because basically it's you need to book the tickets quite early, and we didn't, so we are not the kinds of people that plan their trip. We just go there and see what we can do. So we were lucky to be able to visit it. So is this compute? So I need to find the actual height of my step, which I think is this one. So if I put this instead of this one, that should solve the issue. No, it did not. Crap. So what was it? Oops, taken into consideration or not? No, it was not. So I have some issues with Unity lately. I don't know if it's because I have auto reload or not, but sometimes the code change are not taken into consideration, and it's not recompiling the scripts. So hopefully that's the issue here, because otherwise I don't know how to solve the issue. And apparently that's not. So I was expecting, because I did change this value, so it's absolutely not the same value. So why are you not? Oh, because there is no it. there is no it, so it's this one, sorry. And actually, do I want to have this one as the maximum height? I don't know. And it's still... What? Okay, so I'm not exactly sure. I'm a little above that. So I'm still colliding, and I'm a little above that because this one includes the shell width, which in that case it's quite small. I don't know if it's that or not. But anyway, I should probably not have the shell width. Should I? Or actually, the shell width should also be part of the second vertex. But it is because I removed it from the second vertex. So there is some stuff that's not very intuitive. So basically, when I'm stepping at this position, it would make sense to include the shell, basically, because I don't want to be on the ground, so I do want to be a little above the ground, which would be correct. But in that case, I'm still colliding. It's too fast. Yeah, I'm still colliding much more than... So that's much more than my step. Is this computation okay? At least I'm projecting the position point to my character position on the up vector, and then adding the shell width to be perfectly on the ground. I feel like I'm still much higher than what I should be. It doesn't change much, but should be consistent. Physics up is math up for now. I go the full distance, and the full distance has not been changed, so that's okay. Let's check if if I don't do this part, what happens? I'm now penetrating on this one, and it's ugly. So there is a need for this one, and actually to simplify or to make things a bit more obvious for me. Oops. That didn't move it much forward. Okay, so the height appears to be okay. So the issue is not on the height, on the final height I'm posing, but on the collision detection. So I'm not detecting the collision because I think I'm missing one of these. Because this one is just, the capsule is already hovering over the ground by the shell width. So to compute the step height, I need to compute it from the hit position relative to my player position, but my player position is already above the ground by the shell width. So when I compute the height of my character, I should add again the shell width to have the shell width above him, if that makes sense. And it's still colliding. Because I'm taking the capsule height. There is already up here. Shouldn't change. No. I'm just trying to see what happens now. Again, I doesn't seems. Does it feel like it's taking it? It doesn't feel like it's taking it into consideration here. I mean, yeah, it is. Okay. So that's not my issue. That's not my only issue, let's say. Let's already change this duration to be something that will be only one frame. So this one is no longer colliding, but I should. How much is that? Should I not remove the step? So that would be working, but I should already be able to be above. Because I'm going up too soon, which is why I'm colliding in the stuff, and I'm going up too soon because I don't find the cast. So how much is this? That's the question. So let's add the shell width. This is the why would I need to add? I don't understand why I need to add again 3 times. Here I'm still colliding, so I'm not going up. I'm no longer colliding, so I can go up. And I'm going up. But not enough. That's strange. No, it's too much. Doesn't change a thing, but I don't like to have this kind of solution because I don't understand it, and I'm pretty sure that there will be another case where it just doesn't work. What happens if I move slightly? Still working. And I also don't understand why there is this little steepy step. This one is not colliding. Or this one is colliding. Is it that I am colliding? What's your current status? Your wall. So you're considering you hit a wall. This is not colliding? No. No, it's not. It's not colliding, so it's not colliding, and in that case, why am I not up to this? Okay, now I'm above that, so it's just one. And now with just one, I'm colliding again. That's messed up. Let me put the draw to more than a frame. I'm absolutely not getting to the height I'm expecting to get. So I should be this high, which is roughly what I'm missing here. I don't know why, but let's try that. And this is getting way higher. Didn't find the associated module for the breakpoint. Correct on slide script. Okay, it's not okay. Actually, for that to work, I need to disable everything else. Otherwise, I don't know which one is triggering the step collision. So you should remain, and everyone else should be disabled. And I left the correct one. Okay. Going back point. Okay. So there is no hit, so I should go 0.44. 0.44. And then again 0.23. Let's measure, so create a 3D object cube, scale on Y 0.44. So easy if you want. Does it match my step height? It does. So my first move up should be okay, but why the hell am I not moving up like that? So my current position minus 0.049. Why is my initial position below 0? This plane is at 0.1. And the capsule. Okay, let's. And I remove the breakpoint. Try again. Okay, so my initial position is 0 basically. So let's actually. So we agree that I understand. So I did move up the correct height, but now I'm doing the check to get the ground. So here I'm checking if forward there is something to climb. No, so I'm checking downward. Is there something to step on? And since my last check was a step, I will find something. I will find a support. And when I go into the classify here, I got a very small angle, so it's not a very steep angle, because I'm basically seeing the edge of the step, the step nose. It cannot be climbed. It's not going away from me, no. So I'm not stepping down something. The previous one was a step, so it can't be a step, then it's a wall. And that's why I'm moving sideways. So I need to cheat a little bit. Okay. Continue on this one, continue on this one, so I can stop. And I need to cheat a little bit and consider that basically when I'm doing the ground check, I can consider myself unsupported. So I will correctly classify the step as a step. And on the next frame, keep trying the step. Yes, so that has fixed the little sideways step. And I'm now correct in the testing of the height for the step. I just not sure I fully understand why I need to add back 3 times this. So I need to add twice the shell because I have it below and above myself. And the third time is because I already add it here, and since it's a minus, I'm removing it. So that kind of makes sense, maybe. Anyway, that should be the last issue I have with this collide and slide algorithm. So let me just look if up. Okay. Okay, so stream is still up. That's good. Put that here. Put this one here. And okay. So that should be the last of the tests. So I don't have any more debug. Let's re-enable everything. Okay. And do a final review because maybe I did something. I screwed something else up. So this one is not stepping above because there is not enough space to step on. This one is moving even if the step is weird. This one is sliding. Okay. The next one here is climbing up, down, and facing always the cliff. This one is not climbing. This one is climbing slowly on the side of the cliff, following the wall. Is it stepping up here? Yes, it's kind of stepping up, but that should be fine. This step is to check that I'm still going straight, so that's good. This one, I'm not sure if it's still accurate. So this one is I need another cube to measure the height. Copy, position, paste, position, scale 1 1 1, station 0 0 0. Okay, and where are you? Where are you? need you here. And I need you, so if the character can step 0.75, I need you at 0.74. Okay. And I need you to be flush with the ground, something like that. Okay, and this one actually need to go down a little bit. Okay, and is it steep enough for this capsule? Maximum slope 45, so yeah, that should be okay. Yes, so it is stepping above this one. And actually, if I duplicate that one, actually duplicate the complete group, and you move. Okay, so basically this one is the same test as this one, kind of. I think he's stepping higher than expected. What is my maximum step? 0.75. So let's actually take this one by one, 0 rotation. 0, 0, remove that. So normally this one okay, so if it's 1 in height, it should be, so if I move it up by 0.25, it should be 0.75, and I should barely be able to step over, so I'm not able to step over. That's good. And if I do 0.249, still can't. 0.24, still can't. So why can I not step over this one? Because maximum height is 7.5, and this one should be sitting at 7.4. Let's add some debugs again in the step logic. Step, no, I'm not even drawing the capsule, so am I not considering this as a step at all? No. What's your current status? Capsule is grounded. Does it ever go to something else than grounded? No. So I'm not seeing this as a step. If I rotate it very slightly, Still not seeing this as a step. Okay. So what's happening here? Is this because of the shell? No. Still not. I'm not colliding with this, in fact. Or if I am, I'm considering it as a wall. 0.5. So let's debug this case. This one, disable this, just have this one. I'm in that state and now I will be debugging it. Okay, so currently I'm on the ground, so I move along the ground. Did I move? Okay, so that's my reorientation. Okay, and now I'm with a wall. So the issue is that after this one, okay, so let's continue. Where is my current cursor? Okay. Let's go inside here. We didn't go inside. So this is the ground. So why? Why are you not part? Okay. Okay, and move to next collision. You are not in. Okay, this one is. Okay, casting. I do get a collision. Can I classify this one? Yes. Or not. I just went over the classification logic. Let's stop everything. Recompile and try again the where is my editor? Okay, think the recompilation. Okay, and now I want to be able to do a check when I'm doing the classification. Don't find any. Apparently the notification decided to work again. So you can know which sound you are enjoying, but no clue why it's triggering now. And it's also sending it in the chat, which is new. Okay, so let's not have these start. Okay, so I'm now stuck on this one, and if I stop here, okay. So normally I should be in the ground path, okay. The slope is very steep, okay. I cannot climb that. I'm not moving away from it. It was not a step. The height is wrong. The height is wrong. That's not the height. That's not the height I'm expecting. So this one is wrong. And I am not doing the same logic. So this is most likely my issue. Here I know this logic for this step, which is here. This one is correct. Compute the position of the step nose. Support position minus this one, so that's the height. So that's actually the computation I need here. And the physics up is gravity direction minus the gravity direction. The shell is this one, and the support position is this one. I think I was computing the actual distance, not the vertical component only. And actually I need this name. And why are you not happy anymore? Stop it. Cannot implicitly convert bool 3. Okay, so I need the length of that one. Or can I use the maximum step height times minus the gravity direction? No, he's not happy. Okay, so let's do the length. Of this one. And why are you not reachable? Because of this parenthesis. Okay. Tuck. And I still cannot step over it. So the computation is identical. So what is my current shell width? Entity 005. I don't get. New. Row. New row. So that will be the one I want, and my start position might as well be my current position. So I need to remove. I need to remove it. Okay, so that means there is an issue in my other one, which is why I needed 3 times the capsule. My step is above over there. Okay, so that's my step. I need minus this one. And in that case I should only need 2 here because again, you are just below. You should still be able to climb. Move to the next position, classify the support. You should be able to climb it. So it's a step. Good. Now what? Not a cliff. Moving on the next one. It's a step. Now I'm stepping. And you are not okay with the height I'm colliding, okay. Colliding with something. And there is not enough space. So maybe I do need to be able to cast a little bit above. So there is two different computation for the step height. Continue. Stop this. Okay, and the cast here. Remains a plus. This one come back to a 3. This is still not. Still not working. And if I look at other step, sorry, this one is working. This one is still working. This one is still working. So there is the edge case here. If I put you just a little bit lower again, you are not stepped. Why? How low do you need to go? Okay, 0.2 works. Zero to 4 doesn't. You should work. So let's dive into you. Why are you not willing to work? No, that's the other project. Numerical integration, collide and slide. This one. I really want to fix that stuff to be able to go to the next step. But that's bad choice of word. To try the next numerical integration, the next project. So, why are you not stepping? This one is giving me 0.84. There is a collision. There is a collision. I move. I move 0. What? Oh, no, hide. So I move a bit. Okay. Okay. So my travel distance is updated. Okay. (0.5, 0.3). Why? It considers there is not enough space to step, so I'm not casting high enough. I'm not casting high enough. Let me draw another capsule. I will draw another capsule at the position destination. I'm too low. I'm too low. Vertex 0 is too low. Vertex 0 should be my current position plus the maximum step height plus the radius plus the width. Oof. Not the width. Yes, plus. Yes. Okay. So this is back to working. Step heads on collision. This one is still working, and actually can this work with 2? Yes, which makes sense. Makes more sense, let's say. And can it work with 1? Not exactly. It was better with 2. Yes, so that's 2. Okay. Try again. So this one, we go up to 4, 9. It's still working. Okay. So that's the limit of the step. Okay, okay, and okay. Everyone seems to be happy. That's good. So why were you modified? Let's revert this one. So it's handy that there is a small blue mark on the left to show you that that prefabs have been overridden. So these are normal overrides. Or expected overrides, let's say. And this one is not. This one is not. And there is still an override. Why? Okay, I don't know what was the override. This one is expected. This one is not. What's overridden? I don't know. Okay, so the collision ones are expected because they are basically the physics layers that are set, and this one is expected because that's the one that I want to work around basically. And it should work correctly for everything now. Save. Last check. Who are you guys? These were for the previous stream. Go. And everyone is okay. Last one is this one. Okay, we are happy with that, so I can commit that to Git. So fixed stepping logic, which is basically the only thing that I did here, and we can move on to the next project. So for the numerical integration, so basically that's what will allow the player to have inputs and to influence the direction in which the player will go, and then this collide and slide will handle all the collision response. And for the other project, so yes, close it, disconnect. For the other project, it's not opened, so let's open it. For the other project, I'm comparing, so I created a small script to compare different numerical integration methods to check which one will be the most appropriate for my character collider. So and then from that method I will start implementing basic movement like moving on the planes, jumping and stuff like that. And I want the designer to be able to say how high the character will jump, how far he will jump based on the maximum velocity, how fast he can move, so maximum velocity, and have that all intuitive. So here this little project has basically, and let me re-enable this one, 4 different methods to compare. Euler integration, semi-implicit Euler, Verlet and velocity Verlet. so they are all in the same script, and basically based on the update, I'm on the method that I picked, I'm using one or the other. So if we take a look at this one basically is saying, okay, I want to update the position based on my velocity and the delta time, and then updating the velocity based on the acceleration. So that's the most basic movement integration that you can do. Then there is the semi-implicit, which you will see is a little bit more stable. And basically all you have to do is to invert the two lines. So you first update the velocity and then you update the position. And that gives you something that is a bit more precise, a bit more stable. The Verlet integration, I won't explain in a lot of details, but basically it's updating the position of the entity based on the projectile motion equation, let's say. So basically it's using both the velocity computed from the old position and the acceleration. So that's basically the same equation as a projectile. And then storing back the position, the position as the old position before returning the new position. So this one has the main drawback of not being self-initialized, meaning that you need to be able to have the previous position to compute the velocity. It's not tracking explicitly the velocity, which is the purpose of the velocity Verlet or velocity Verlet integration, in which we update the position based on the velocity and acceleration. So half of the acceleration is applied each frame. So we apply half of the acceleration from the previous frame and half of the acceleration from the next frame, from the current frame basically. So we track all of that. We track position, velocity and acceleration. So that's a little bit more state data, but we'll see that it's basically the most stable version. What else? For this code, I've introduced in the update some random sleep to simulate instability in the frame rate, to not be too close to a fixed simulation. And we can do that in fixed simulation and fixed update, and update. Also in late update, but that's basically the same thing as update. So if we take a look at our implementation here, or scene rather, let's zoom out a bit, and you will see that we will have basically put it on the fixed step. So let me start again. So I will put it on update first. Don't mind this parameter, it will be used only for the fixed update. And if we look at this, we can see that the simulation is with different accuracy, let's say. Is it really using? Yes, it's using the update. So if we look at the Euler one, so the blue one, you can see that every time I drop the ball with the same initial velocity, same initial position, I am not following the exact same path. So it's not very accurate, and you can see that it's also above all of the other ones except for the red one, which I will come to later. The semi-implicit is the orange one. So the orange one, same thing. It's a bit more, maybe a bit more stable, not even sure, compared to the blue one, but it's below. So it's not doing the exact same, or not keeping track of the exact same trajectory, the exact same energy. The Verlet integration is the red one, and this one you can see is completely wild. That's mainly because the way I'm doing it is that I'm setting the velocity, and when I reset the sphere, I'm computing the velocity, the old position based on the velocity and the delta time. But since the delta time is not stable, basically the old position will not give me back the same velocity. So it's completely wild in terms of path, and I can already tell you that I won't use this one. And the last one is the velocity verlet. So it's the same principle as the red one, but instead of recomputing the velocity every frame, I'm keeping track of it as a state. And I'm also using half of the acceleration from previous step and current step to update my velocity. And you can see that it's the most stable, the most accurate, presumably, because it's in between the two other ones. So it's for now, with variable frame rate, it's the best integration method. Now, since I'm going to use that for a character controller, the update of the character controller will happen at the same step as the physics update, which is in fixed update. So what we actually might want to do is to look at the fixed update. And for that, I will use a fixed update of 120 frames, and we'll see what it gives us. And I just updated only for the velocity verlet, so let me go back here, go back to the update or to revert, and change that from the prefab so that it's changed for everyone. So same color, just updating with fixed update, and you will see already some noticeable changes. So apart from the first one that is completely strange for the red one, they are basically all following the same path. It's very accurate, it's not going wild on anything, even on the verlet integration, and that's because the time step is constant, is fixed, so there is no miscomputation, let's say, of the velocity every frame. But that's with very high update, so I don't think any games is updating the physics at 120 frames per second. So let's change that and instead do something that is more reasonable, let's say 50, which is the default, I believe, for physics, so for monobehavior objects. For dots physics, it's 60 FPS, so it's not exactly the same. And let's see. Here we can see that there is a slight change, so not everyone is going into the same spot. We don't see the red line because basically the red line for the verlet integration is the exact same as the velocity verlet, because the fixed update nature of the time step makes it that it's as precise, basically. And let's see what happens if we drop again a little bit more on the integration. So let's do 10 frames per second and see what happens. So except for the first frame that is probably a misinitialization again, basically all of them are again diverging. The only one that is probably, and I can try that with my little screen capture. So let's capture that. And basically I think that the green one is the one, or red one in that case also, is the integration method that is less impacted by frame rate, or is less frame rate dependent. So let's go back to something more reasonable, so something quite not reasonable but quite accurate, 120. So So we can look at the integration. Okay, and let's put above. So as you can see, the green one here, so the velocity verlet, is following the exact same path, whether it's running at 10 FPS or if it's running at 120. So that's probably the best numerical integration method I can get to be accurate on the physics of the character. And that's the one I will choose. Now, there are some disadvantages to it. So if I go back to the code, there is one drawback, which is the fact that I need to keep track of the acceleration in addition to the velocity. So this will be more costly in terms of memory because I need to keep track of that for each entity, and it's something that basically it's a state data, so it's an additional data for the state of the entity, and that's the kind of thing that we need to synchronize over the network if we are doing a multiplayer game, which I'm trying to do. So can we change something here to not have to track the acceleration, basically? And still keep the same accuracy. So let's create an additional method. Let's call it modified. Okay. And for this one, I basically I don't want to do that. I don't want to have this change done. So let's remove this one. But I do need the acceleration. So to update the position, I do need the acceleration. So what can I do? Can I consider that I'm always applying the full acceleration, which is my new acceleration? We'll see if that gives me the same path. So that's something that I don't know. I need to experiment with. Modified one, okay. And we can go back to where it doesn't compile and say this one is the modified version and this one is the modified version. Okay. So let's create another object. This one will have what color should I use? Let's use something like yellow. Let's actually disable the other ones to see if we have the same. So we are going to be in fixed update, so that's fine. We are probably not going to be at 120, so let's put it back as a default of those dots, which is 60. And let's see if that has an impact or not. So I can avoid tracking the acceleration. And it doesn't seem to have an impact, so that's good. That means that I don't have to explicitly track the acceleration. I can just compute the acceleration every time. But that's only if the acceleration is constant, like in the gravity case. So every time there is a change in acceleration, I will need to take that into account and have the acceleration of the previous frame and acceleration of the current frame averaged, basically, because that's what I'm doing, adding both and divided by 2 to do the proper update. So like when I'm jumping, so if I'm jumping, my current vertical acceleration is 0, but as soon as I have jumped, it should be a constant acceleration throughout the jump, mostly. So when I'm jumping, I should apply my initial velocity and half of my acceleration, basically. That's the idea. Same thing for starting the acceleration of the character and stopping and stuff like that. So that's what I will need to keep in mind for my simulation to be accurate. So let's actually do something like some sort of character controller. So let's create, and here I'm not exactly using dots because it's just basic math computation. Basically, there is no need for the physics. There is no need for the colliders and stuff like that. So I'm just trying to do basic movement, and then I will merge it back with the collide and slide for the collision response. And this is quite polluting that there is this chat every time the music changes. There is already the notification on screen, so can I disable that? Current song, display songs in chat. Let me try display the song in chat, so that's not it. Song name. Okay, so I will no longer display the song. That's good. And let me clear my chat so I can see if anyone is talking. Good. Okay. Okay. And so let's start with a very simple character controller. Let's create a capsule. Okay. 0, 0, 0. And actually, let's create an empty parent. Again, this one. That one. Disable those. And add a new character controller. No, it's already taken. So movement controller. Okay, simple basic script, a new one. And let's why are you complaining for the numerical integration? Forgot this one. So actually let's if it was not compiled, let's play it again. And actually did I actually change the method? No, I didn't even change the method, so that's why it's exactly the same. So let's hope it's still the same. Not exactly. Not perfectly exactly the same, but is it actually akin to the semi-implicit? Did I recreate the semi-implicit layer basically? Yeah, I think so. semi-implicit as again changed. I need to change the color because it's blue. Okay, so the blue and orange one are the same, or the blue and yellow one are the same. So actually I did recreate exactly the semi-implicit. And if I drop the oops, not on this one. Actually, okay. 120, 120, semi-implicit. Let's put all of them back again. Okay, so yellow and orange are the same exactly. And if I drop down the FPS for that fixed update, is one more accurate than the other? No. So I've got the choice of either keeping track of the acceleration at the state data or using semi-implicit Euler integration. Because this one is basically the semi-implicit Euler integration. It's just that I'm... So where is this one? Updating the... gravity. Yeah, acceleration plus velocity and then position update. And this one is having the new acceleration, which will be basically, I assume, the same as the acceleration. Yes. Then I update the position, then I update the velocity. So if I do that, it's even more will that get me to the same as implicit as the velocity valley? No, it's worse, much worse. Okay, so that's not a good idea. But if I remove this one, I'm back to the implicit. Update the velocity with the acceleration, update the position with the velocity. And the acceleration is defined every frame, so I'm back to the semi-implicit. Yeah. So if I don't want to track the acceleration, I need to use semi-implicit. Will that be precise enough? I'm not sure. So we'll see with the jump, because I think it's the most sensitive mechanic, the jump. So actually, let's change this stuff a bit. Let's say we are jumping. So we start at position 0. Okay. We have a constant acceleration of this value. And we have an initial velocity. And I want to compute the initial velocity based on the height of the jump. And I don't remember what the formulas are. So let's try to take a look at the initial project. Git, DOA, assets, game, scripts, locomotion, runtime, and I lost my chat window. Okay, it's there. Locomotion parameters. So the initial velocity was 2 times the jump height. Twice the jump height. There is no gravity in there. Maximum speed, so that the time I need to reach the height. So let's say I want to jump float jump height, say 10 units, and public float jump time to peak, time to jump peak will be explicit, will be 0.5. Okay, F. My initial velocity will be mass dot up times 2 times the jump height divided by the time to peak. That should give me the jump height I expect. Then might have been a bit big. And I'm not moving sideways, so I just want to also move sideways at the same time so I can see the curve. So I will, what was the direction? X plus mass dot height. That should give me X times 10. don't think that's 10. That seems big. Is that 10? Let's create game object 3 cube of 10. Oops. Yeah, 10. It's absolutely not 10. So do I need to square this one? Tac. No. What was the GDC talk that explained that? GDC better. This one. Too much sound. 0 is 2h over time and gravity. So I'm not applying the correct gravity. That's why. So 2h over time, that's good. So I don't need to square that. But I need to change my gravity acceleration. Will be equal to what they minus 2h, so negative, good, time h squared. Okay, so same thing. Negative, and this one is squared. So that should give me a height jump of 10. And it's not. And that's because this one is not applying the correct acceleration. Again, and that's 10. It's just that I'm starting at more than 10. I'm resetting at more than 10. Okay, so it seems that I need to keep track of the acceleration because otherwise it's not gonna be great. Or do I need to have the reset done differently if it's this one. If it's this one, I also need to update the velocity by half my acceleration. Because that's what I was saying earlier, if I'm not, that's not helping. It's actually not moving at all. I just killed the entirety of because acceleration times time dot delta time. Okay, so that's not accurate either. I don't know what's the issue with this. I'm resetting the state, and when I do the update, okay, so I guess it will be much more complicated if we don't track the acceleration to have precise control over the jump height and other parameters like that. So we'll sacrifice the bandwidth for the multiplayer game and the memory for the let's say for all player games for tracking the additional float 3, which will be the acceleration. Okay, let's do that. And actually we kind of already have the jump, but it's very simple. So let's do public float 3 horizontal velocity. And actually let's do float just for the horizontal velocity. Let's have a reset method just like in the other one. And this one we will reset just the position. Okay. And we'll set the velocity equal, so we need a public float velocity. Actually, that needs to be private. That can't be private because it's a state data. Velocity, and that velocity will be mass dot height times horizontal velocity. Okay, and let's pick back the Verli integration method here. Put it there and simply call it. So our position will be equal to the return of that. That is our current position. I didn't pick the correct method. This one is a Verli, and I want the velocity Verli. Velocity Verli. Sorry. Okay. And it's midnight. So I want this one. So I do want the position. I want a ref of the velocity. So actually velocity doesn't really need to be a ref. In that case, because it's a state variable, but yes, we can. It's probably cleaner to make it explicit that they are not the same thing. So let's call this one underscore velocity. Okay, and that needs to be updated, so I can put ref. The acceleration, it's the same thing. Let's do a underscore acceleration. Okay, and the delta time is simply time dot delta time, and we said we would be in fixed update. Okay. So resetting the state is this one, and the acceleration needs to be reset also. Acceleration out 0. And I want to reset if my transform position dot x is above 10. Reset state. So that should give me something that moves to the side and revert back to 0. Not moving at all, okay? So let's put them public to see if they get updated. And actually on start I'm not setting it, so void start, reset state. And that's not moving. And that's maybe not compiled. Okay. Oops. Okay, so now I have everything. Okay, and now you're moving. So it was not compiled. And it is moving as expected. So let's let it go a bit further. Public float out of time. Okay, and if it's out of time, and the default will be 30. One, two, three. So over there it should warp back. Okay, that is good. Let's also do the draw new line from the I need the position before, so hold position. Okay, from the old position to the new position. I kind of like the green line, being that everything will be okay. And let's track it for 5 seconds. Let's see if that's enough based on the speed at which we are moving. Okay, so that's enough. And now we can try to implement a jumping logic somewhere in there. And actually in the correct method would be great. Movement controller. Let's close this one. Movement controller. In here, let's rename that move so I don't confuse the other with the other method. And now I need my jump height. Public float jump height. Okay. Jump actually, let's look back at my other parameters. Those are all the parameters I had for the jump. So I can copy those here. And the max speed, let's rename this to max speed. Oops. Okay, initial velocity, gravity ascending, gravity descending. And we'll assume first that we will assume first that the jump is symmetrical. So we'll have a 0.5 symmetry. So I need to update. Where do I need to update my velocity? So let's create another probably be better to put it in another method, but I don't want to handle the parameters, so let's just if input dot key down key code space and position dot y equal 0. So basically, yeah, that's my kind of grounded state. That's a basic interpretation of it. So I want to get my initial velocity, which is here. Okay, and I want to update my velocity. Cannot access non-static property in static context. Okay, so don't be static. I don't know why it was static. Okay, and if my y position is above 0, that means I'm airborne, so I'm jumping, and in that case I need to add to my acceleration the get jump gravity ascending. Let's see what happens in that case. I'm not moving anymore because I renamed the stuff, so I do need to put some parameters for the jump, otherwise I'm jumping at 0. Yeah, none, okay. So 10 for the jump height, jump length, let's put 10. Also symmetry 0.5. Minimum jump height, let's put 10 also, I don't use it yet. And let's try to jump. Ooh! That was unexpected. That's basically, I'm not using I'm just using the value, I'm not using the math. Dot up vector, which would make sense, and this one is adding a gravity, and that gravity should already be negative, so that's okay. Quick fix for that. And there is an issue with my So already that's not 10 in height, and that's certainly not 10 in length. So velocity ascending, initial. So let's go back to the one. Let's go back to this computation right here. State, reset state. Initial velocity. Here, the initial velocity is this one and acceleration is this one. So let's pick those. Okay. Jump height is this one. Time to reach the peak. Let's hardcode it to 0.5. And cannot convert float 3. So I remove the mass up. Okay. And same thing for this one. It's gonna be max jump height and 0.5f. Remove the rest. Okay. Next one. And I forgot to put it negative for the acceleration. So it's not a jump, it's a takeoff. That's not 10. What are you doing? That's not a jump height of 10. Are you kidding me? So I'm not applying it at the correct point, I assume. So let's do it before anything else. And a new acceleration. I need the new acceleration. Still not it. Did that recompile? Compile error, script has error. Okay, so now movement collider line 48. So that did not compile. So force it to recompile to be sure, and hopefully we can jump correctly now. Is that 10? Doesn't feel like 10. Let's create a 3D cube. I mean, if that cube is 1, what's the scale of this stuff? Ah, Okay, so that's a perspective effect, sorry. Let's do 0, 0, 0. Okay, move you a bit there. 10 in Y, move you by 5, and that's absolutely not 10. So should I do like that? Gravity remains constant. I need to figure out where to put the update of each parameters. Let's wait for the next one. Still not 10. And I need to, when I hit the ground, to set the velocity dot y equals 0. Otherwise it's getting below the ground. It's no longer jumping. No, 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 and no. So, guess I will figure that another day. We already have the collidance slides that's working, so that's already a great step. And we just need to, we have identified that we want this method, so the velocity verlet integration method, keeping track of velocity, acceleration, and position, so that we can get hopefully precise jump at some point, because it was working for this one, it's not for this one, so I need to understand where I need to put this stuff with the input and so on. Maybe I should, because basically that's what I'm doing. I don't know. So I will figure that out another day. Thank you for watching, thank you for joining. I will try to keep working on that off the stream, and maybe next time, probably on next Monday, I will be able to share with you some insight into this numerical integration for the character controller. In the meantime, if you are interested in learning dots and you want to support me, you can check out my YouTube course on YouTube. It's free. It's a complete tutorial series of 10 episodes where you will build a tower defense game using ECS and dots principles. If you want to support me and have some of your eyes on some of the assets of the asset store, you can use the asset store affiliate link in the chat and in the description below if you are watching off the VOD. It will support me at no additional cost to you, and it's greatly appreciated. Same thing with Humble Bundle. There are some good bundles, and there will be some bundles coming back, I believe, next week for a few hours, or in the coming days for a few hours. So if you want to check that out, And if you want to support me more directly or have access to exclusive content, including the last episode or the last source code for the Dots tutorial series, you can have a look at my Ko-fi page to give me a donation. Any amount is appreciated. So thank you again for watching, for joining, for your support. And if you like the content, share it, because like it, share it, comment. It gives engagement, it gives a boost to the videos and the tutorial series if you are watching the tutorial series, for others to also learn. And it will also help me reach the monetization goal for YouTube, because I know there are some adverts on my channel videos, but I'm not getting any money from that. So if you can help me reach that goal also, that would be very much appreciated. So thank you again for watching. See you in the next stream, most likely on Monday, same time, same place, both on Twitch and YouTube. And I wish you a good night, afternoon, day, wherever you are, whatever you are doing. See you. Bye.